Okay, so we did it till like this point, which is okay. Now, oh crap. Okay, going forward now. So now we're gonna do case 3, and in case 3, look at two bodies being pushed or pulled together. Now suppose there is a object like this, so this object is x, this object is y, this is mass m, this is mass 3m. Now they say there is a force acting just like this. Now what you guys need to understand is that between these two forces, x will apply a force Fx onto y, and y will apply an equal and opposite force at x, Fy, and that's why, because I told you due to Newton's third law. Again, we have to do the same thing, and the first thing you should always do when two bodies are connected is to find the acceleration of the whole system. So I'm going to find that. So acceleration would be F equals to ma. The total force on this is F, m plus 3m times a. So this will be F equals to 4ma, and acceleration will be F over 4m. Is it clear, everybody? Now you can pick any object, whether x or x or y does not really matter. So if you pick x, so on x there are like two forces acting. There is F and there is Fy. So you can just now apply F equals to ma, and you could say, okay, the resultant force will be F minus Fy, because it's in opposite direction, m times F over 4m. I just replace the acceleration there. M and m will cancel out, so it is going to be F equal minus Fy equals to F over 4. Now if you want to find Fy only, this will be F minus F by 4. That comes out to be 3 by 4F. Is it clear, everybody?
Yes, sir.
Now you can also, or if you want to find what is, well, Fy and Fx are same, we know, but if you really want to, prove it or otherwise, you can take the other block as well, y. So on y, there was only one force, which was Fx. So I'm gonna say, okay, F equals to ma. There's only Fx. The mass of y is 3m, and the acceleration is F upon 4m. M and m will cancel out, which will leave us with 3 by 4F, which is the same as the Fy because they are action reaction forces. Is it clear? Any questions? Let me know. Okay. Now we're moving towards case 4. Case 4 is when they give you two objects connected or attached with a wire over a frictionless pulley. Now suppose there is a pulley like this. There is one object that's here, and there is another object that's here, like this. Okay. This object is m1 and this object is m2. Now they say that m1 is 30 kg, m2 is 60 kg, and they would generally say find the acceleration. Okay, and after that there could be like an additional question from kinematics or something. Now, so you guys need to understand that the weight of this, let's call this weight 2, will be equal to m2 times g, and the weight of this will be m1 times g. Is it clear, everybody?
Yes, sir.
Yes, sir.
Now if you notice this, although both the weights are acting down, but do not mistake it for the same direction, because if you remove the pulley and put them like in a line, you'd realize that actually it is pulling it this way with m2g, and the other one is pulling in the opposite direction, which is m1g. It is not the same. Is it clear?
Yes, sir.
Yes, sir.
So now the equation is going to be F equals to ma, W2 minus W1, because they are over the pulley, they are opposite in direction. The masses would be m1 plus m2. You add the masses, you find the acceleration. So this is going to be 60 times 9.81 minus 30 times 9.81 equals to 60 plus 30 times A. Now simply use your calculator to find it out. So this is basically equivalent to 3.27 meters per second square. And then they can say, okay, maybe tell us the length or something, it moves or something in time, whatever. So it's up to you, okay, what you want to do. All right, now so then in case 5, like two objects connected by a wire over a frictionless pulley on an inclined plane. Now, this is a tough one. I mean, it's not really tough, but you just need to, understand. It could be a table as well, like a flat table, or it could be like I've done the first one. So suppose this is 30 degrees. There is an object like this. There is a pulley like this. So this object is connected to the pulley, and then there is another mass right here which is pulling it down from that side. Suppose this is 2m, this is 4m, and they say that they have shown a force like this as R, and they say the friction F is 0.5 R. Now, please understand that they have just said if the mass of circle is 2m and mass of the rectangle is 4m, calculate the acceleration. Now nothing else is given, right? So this is quite difficult in that sense. So let me just tell you how to do it. So the very first thing we always do is make the components of the weight. So the weight always acts downwards, as we all know. One component of the weight acts down the slope, and one component acts perpendicular to the slope. This angle is always the same as 30. So here I just want to tell you this will be W cos theta or 30, and this will be W sine of 30. Everybody understands this? Now interestingly,
Yes, sir.
here, if this is W1, this is like another W2, which is basically pulling it, which is causing a tension in this wire, which is actually pulling the whole system downwards or the circle upwards, right? So, two things you guys need to remember. Number one, that W2 basically will always be equal to the tension T in the wire. Number two, W cos theta, I mean W1 cos theta, will always be equal to the reaction on the object. Is it clear? Now,
Yes, sir.
now check this out. So when you make an equation along, like I said previously as well, along this wire, so we are looking at this wire and an equation along this, because W cos theta, W cos 30 basically balances R. So we should know that the tension, let me choose another color actually. No. The tension T,
So why is it angle 30?
who asked?
Rami.
Okay, Rami. Nobody asked me anything like that, Rami, when you were not there.
Why?
I don't know.
Am I that dumb?
No, because I think others were like, okay, if sir is saying, let's just believe him. Rami's like, no, I don't want to believe. So basically, if there is an object like this, the weight will always act downwards, Rami. You agree?
Yes, sir.
One component down, one component perpendicular to the slope, right?
Yes.
This makes, now because Ramin has asked it, so let's do it. This is 90 degrees, do you agree? If
Yes.
this is 90 degrees, what is this angle then?
60.
If this is 60, can you tell me what is this angle?
Oh, yes. 90, and that will be 30.
How's that, Ramin? Okay.
Yes, I got that. Thank you.
Okay, so basically you guys need to just believe me. What I'm telling you is correct, okay? Alright, but you can also question, that's fine. It improves your understanding. So basically there's F acting downwards, T upward, that's why I put a minus sign. And then minus W sine 30, and that's all the forces on that line, is equal to MA. So for M, basically I'm doing F equals to MA, okay, if you don't know. So MA means we have to add, where they're connected, so we have to add both the masses together and multiply for the acceleration. Is it clear, everybody? Now it says friction is 0.5 of R. We already know what is the value of R. So what are we going to do? Tension is basically equal to W2, which means it is 4 mg. You guys agree? Because this is
Yes, sir.
4 mass times acceleration due to gravity. Minus friction is 0.5 and R is W1 cos. What is W1? That is 2 mg cos of 30. You guys agree?
Yes, sir.
Minus W1 sine 30, which is 2 mg sine 30 equals to 6m times A, right? Because each term has a mass, so we can cancel that out. Just like this, which leaves us with 4g minus 0.5 times 2g cos 30 minus 2g sine 30 equals to 6a. And now let's put in the values of g. We know g is 9.81. Cos 30 times 2 times 9.81 sine 30 times 6a. So now let's do this. These are basically very similar questions to the ones you will do in math M1 if you've taken math. And basically it is physics really. It's called mechanics. So we are also doing mechanics right now, but in physics for some reason. Okay. This divided by 6. Okay, so acceleration should come out as 3.5 meters per second square. If a question doesn't tell you about the mass of an object, please do not worry about it, because the point of this is that eventually when you make the equation, the mass is going to cancel out. So you don't have to worry about it. You just need to focus on making the right equation in one line where all the forces are acting, not the balanced ones. Is it clear, everybody? Any question here? Because I know that this is a bit tricky one. Right. Okay. I hope everybody is clear. Now, about 10 minutes time, the meeting is going to close, but you have to rejoin. Of course, you should know. Now, moving. If you have any questions, please ask. Otherwise, I'm going to go forward then.
No questions, sir.
Okay. Now, there is something called law of conservation of linear momentum. Now, when you basically look at any law in physics, it means it cannot be broken. It is just a fixed thing that will always happen. So between law and a theory means theory can be disproved, but not the law. Now, whenever they will ask you what is the law of conservation of momentum, the definition of this or the law has 2 marks. So for 2 marks, what you're going to write is, for the first mark you're going to write, I'm going to break it down so that you guys can remember. In an isolated system. When I say isolated system, it means that this system has no unknown forces. All forces you know. So in an isolated system, the total momentum before a collision is equal to the total momentum after a collision. So this is the law. So 1 mark for writing just in an isolated system, the rest for 1 mark. Now, what it basically means is, suppose you got one object m1 which is going at a speed of u1, and then there is another object m2 which is going at a velocity of u2. So this is happening before they collide, and after they collide, m1 is now going at a different velocity v1 after, and m2 now after collision is going at a different velocity v2. Alright? So what the equation tells you is that m1 u1 plus m2 u2 is equivalent to m1 v1 plus m2 u2. So this is the total momentum before, and that is equal to the total momentum after, and this is the general equation you guys need to remember.
Sir, M1 V1 plus M2 V2 नहीं होगा?
Yes, that's correct. Sorry, v2. Okay, so this is the general equation we gotta remember. Now case by case we're going to discuss this. So first of all, you guys have written, right? I hope I'm not going too fast. Okay, so case 1 then. Case 1 is when two bodies collide and move away, like they separate, right? So in that case, suppose there is a body m1 that is 2 kg. It is going at initial velocity of 10 meters per second. Let's call this u1. There is another body m2 which is 5 kg, and it is going here with u2 equals to 20 meters per second. Now this body is after collision, m1 basically, which was 2 kg, moves in this direction, v1 as 6 meters per second, and this object, which was basically m2 5 kg, we don't know the velocity or the direction of this, and we got to find that, right? So what you're going to do now is write the equation first, right? m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Then in step 2, assign the signs. What I mean by this is, if let's suppose we take right side as positive, then all the vectors to the left must be negative. You can do otherwise as well. Is it clear, everybody? Now what you're going to do is write the equation. So first mass was 2, and then because it was going towards the right, this will be positive, this will be negative, this will be negative, and I don't know about that one. So u1 is 10 positive, m2 was 5, u2 was minus 20. Then this one is 2 again, and it is minus 6. This is 5, and we don't know what is v2 yet. Okay, now so this is going to be 20, this is going to be minus 100, this is going to be minus 12 plus 5 v2. So this is going to be minus 80 equals to minus 12 plus 5 v2. You take minus 12 there, it is going to be minus 68 equals to 5 v2. And now if you divide 5, you should get an answer minus 13.6 meters per second. Now you got the value, but the important fact is that if you look at the negative sign, so the negative indicates that according to our sign convention that we have taken. Okay, I have told you before as well, you can take any other convention as well. According to our sign convention, M2 moves to left. Is it clear, everybody?
Yes, sir.
You can also do it the other way around. It would not change anything. Like if you try, okay, if you say, okay, we don't want this, we want negative here on the right and positive on the left. So show us if it changes anything. So then it would make 2 times negative 10 plus 5 times 20 and 2 times 6 and then 5 v2. So if you do that, it's going to be negative 20 plus 100 equals to 12 plus 5 v2. So this will be 80 minus 12 equals to 5 v2, and this is going to be 68 equals to 5 v2. So v2 this time will come as just 13.6 and in the positive value. Because we took positive on the left, so it's still going to left. It does not really matter what you take, but if you have taken right as negative, then all the vectors on the left must be positive. Do you guys understand now?
Yes, sir.
Okay. Now, let's move to the case 2. So in the case 2, and this is the most recurring question, 2 objects collide and they move in unison. Unison means the words they're going to use, basically the keywords, go together, stick, embed. These are the words they're going to use. So the moment you should know that they've used this word, it means this is case 2 and you should remember this. Okay. Basically what it means is that suppose there was a body which was 2 kgs. It was moving at u1 like this, and there was another body that was 3 kg and u2, and it was moving in this direction at 4.0 meters per second. Now, so this is what is happening before, and afterwards they both stick together somehow. Okay, there's a possibility, and now they're going at a velocity and we want to find that. We don't know the direction as well. Is it clear, everybody?
Yes, sir.
Now what you're going to do is when you write the equation, so write m1 u1 plus m2 u2, the general equation, m2 v2. You're going to assign the signs. So I'm going to write positive on the right, negative on the left, because I like this way, but you can actually take anyway. This will be minus, and that we don't know. So now let's do this. M1 is 2 and it is going at 1.0. M2 is 3 and it is going at minus 4. Okay. Okay, let's wait 1 minute for everybody to join back. Okay. So this is 3 minus 4, and then when they say this go together, now they're sticking, which means we're gonna add their masses together, and now they're moving at one single velocity. Do you guys understand this?
Yes, sir.
Remember this point, and this is very important. Now, so this is going to be 2, this is going to be minus 12, this is going to be 5v. So if you subtract, this is 10 equals to 5v, and v is going to be minus 2 meters per second. Minus, of course, indicates that it is going to the left, and 2 is its value. Is it clear, everybody? Any questions?
So that's it for today.
Why, Ramin? After 2 days, you're taking the class.
Because I'm speaking.
Because you want to speak to me?
No, because I'm sleeping.
No. I actually want last case to be done before we end the class. Okay, Ramin? Just case 3.
Okay, fine.
Okay. How do you take classes at school? They have 1 hour 10 minutes class.
No, that's different.
Okay. That means you don't study at school then. Like always, you know.
No, I do, but that's a different vibe, maybe.
Okay, I'm offended, but okay, fine. Last case. Case 3. Case 3 is when a stationary body recoils or explodes into 2. Okay, so basically recoiling is an effect. Who plays PUBG here? Anybody plays PUBG? Fortnite or something like that? Call of Duty? Nobody plays any game? What? Anyway, it's interesting. Basically, recoil is an effect where if you fire, a gun or a cannon or anything like that, okay, even when the molecule, breaks, so there's a cannonball inside, so they are basically one body. So let's say this is M1, which is 5000 kg, and this cannonball is M2, which is 600 kg. So before they explode, their initial velocity will be 0. You need to understand. When they do explode, what happens is that the cannon would recoil backwards. It will move backwards, and the cannonball will move forward, and that's what happens. You can actually check some cannon firing videos as well. So suppose it goes at v1, which is 5 meters per second, and we want to check what is v2. Okay, and this will always be like in opposite directions. We already know the direction, so it's fine. So what you're going to do is assign the signs. Let's take positive here. So first one has no sign. This is positive, this is negative. So now I'm going to write the equation. M1 U1 plus M2 U2 equals to M1 V1 plus M2 U2. Initially, both of them are 0 because they're not moving at all, so the momentum is 0. Afterwards, m1, which was 5000 kg, moves with -5 because in the opposite direction, and this moves with 600 kg with v2. So you take 5000 there, it is going to be 25,000, and this is going to be 600 v2. So the v2 is going to be then 25,000 divided by 600 is going to be 42 meters per second. Do you guys understand this? Pretty easy, right? So these are the 3 different conditions they're going to ask you about, and that's it from law of conservation of momentum. So inshallah, in the next week we are going to finish this topic, and then we're going to start with our worksheet. Okay, bye. Have a nice day.